Good afternoon, Physics 30. Hope you guys are all doing well. Welcome to the very last video lesson of this chapter. So that means this is the last piece of light as a wave, and then we'll be going on to our next chapter with light as a particle. So that also means this is the last video lesson for your EMR Chapter 1 assignment, and I hope you guys are doing okay with that. And if you guys have any questions, sign up for my lovely Google Meet office hours. Okie dokie. So this one is all the lessons we've probably done. This is probably a really easy one. The lesson's not going to be super long in comparison to the previous lesson. Oh man, that was a huge video. Huge tech disaster too, but we got through it. So this one, ladies and gentlemen, we're going to be looking briefly at comparing refraction and diffraction, and then on the next page we'll talk about polarization, and that's it. All right. So, ladies and gentlemen, so just remember that refraction is our bending of light, or EMR, as it's going to pass from one medium into a new medium. So here's a lovely triangular glass prism. And so what Newton did with it is he shone some white light. So white light is just any light, all light, okay, that we normally use day to day in your light bulbs. And he shone through a glass prism, and it broke up into a beautiful rainbow spectrum. Now, what happens with this spectrum, the reason why a prism or a raindrop or what have you can break up white light into a spectrum is because it is going to be refracting each of the different wavelengths of light. Each of them is going to have a different index of refraction, each wavelength. Okay, so ladies and gentlemen, red gets bent the least, violet gets bent the most. Remember that red has the largest wavelength and violet has the shortest wavelength, therefore highest frequency, lowest frequency. All right. So the formal name for this is called dispersion. So when you're going to be using refraction to separate EMR into its different wavelengths. Okay, so just remember, white light is made up of a whole bunch of different wavelengths, our whole beautiful Roy-G biv here. And each color or wavelength is going to be bent at different angles. And because it's being bent at different angles, it's going to be separated into its pretty colors. Okay, so, and this is because they're going to have different indexes of different indexes of refraction. Okay, write that down. Your shorter wavelengths, as we already mentioned, are going to refract the most. Longer wavelengths refract the least. And so we have a pretty rainbow. Awesome. And we would have definitely played with prisms in class, but we're not in physics class. We can't play with prisms and laser beams. It makes me sad. Okay. So, ladies and gentlemen, here we have a slit screen here, and this one just have one slit, and we are getting some lovely diffraction here. So the spectrum produced by refraction, so what we looked up here, is going to be opposite to the spectrum produced by a diffraction grating or a double slit screen. So when it comes to diffraction, your high frequency waves here, so your short wavelengths, are going to diffract less, and the long wavelengths are going to diffract more. So when you look back at our previous lesson, we did a whole question on that one. So keep that one in mind. So this bit is just a review of what we looked at in our last video. Okay, that's it for that topic. Like I said, very, very quick, probably one of our shortest video lessons. So we're going to switch gears a little bit, and we're going to talk about polarization. Polarization, you guys have probably heard in context with polarized glasses, polarized sunglasses, and your polarized skiing and snowboarding goggles. I'm a huge fan of polarized lenses. This gives me an opportunity to show off my awesome specs. So You can even see these. This is the glasses where it's lining up with my the start of my summer face tan. Because I always wear a baseball hat and sunglasses, so the top half of my face is pale and the bottom half is tanned a little bit. So I pretty much live in these awesome specs outside in the summer. And prescription lenses, polarized, they're awesome. And I really like polarized lenses. It really cuts out a lot of the glare from the sun and actually protects your eyes significantly more than just tinted lenses. And if you go and buy like the cheap $15 gas station sunglasses that say, hey, they're polarized. Well, they've got some cheap spray on it, which will polarize them, but you clean it once with a good cleaning cloth or a good glasses cleaning spray and it removes the film. So yes, if you get the fancy prescription sunglass lenses, or if you want to keep the polarization in them in your glasses, yeah, sure, go buy the polarized Oakleys or whatever. Yeah, it's going to cost you an arm and a leg, but it's actually going to protect your eyes. Because the thing is that tinting your lenses actually doesn't protect your eyes as much at all. It's the polarization that protects your retinas. Because what the polarization does, as you can see here, is it takes the EMR and it gets it from going in wavelengths that are all in different directions and gets it going into one. It streamlines it. Okay, so as you can see in this diagram here, you've got the sideways EMR. So this could be, I don't know, the magnetic portion of your field, and then the electric portion could be this blue guy going up and down here. Well, what this is doing, the polarizing film is filtering out everything except that blue bit, and it's keeping it all nice and neat. Okay, and you can also have a sideways polarizing lens that's going to get rid of these vertical ones. So that bit is actually going to protect your retinas, and it's going to make sure you're not going to fry them with all that excessive energy. And if you have just tinted sunglasses, what it's actually going to do is it's going to cause your pupils to expand or to dilate in order to get more light in, because your brain is thinking, oh, well, it's dark, I need to expand them. So your pupils will expand, but there's nothing to filter out all that burning light, and you're just going to let more of this zapping light into your eyeballs. So polarized lenses are actually going to protect your eyes a lot better than just tinted sunglasses. So I do highly recommend getting proper polarized lenses if you're able to. So, and if you're not able to now, well, consider getting some in the future sometime if you can do that. So there we go. And besides, they last pretty good. I've had these sunglasses for absolute ages, and they're pretty cool. All right. So, ladies and gentlemen, with your non-polarized light, it can vibrate on all sorts of planes, okay, up and down, back and forth, okay, because remember, it has both your magnetic and electric components, okay, and as we've already talked about, we'll just get these notes highlighted for you. It is possible to filter out all but one plane of the oscillation of your EMR. Okay, now in class, what we would have done is we would have definitely played with two different polarizing filters and canceled a laser beam to nothing. It's super fun to do. So every polarizing filter is going to have an axis orientation that's going to allow light to pass through on the same plane. So this polarizing filter is going to filter out all of these other wonky side ones and only let the vertical ones through. Whereas this guy here, he's only going to let the horizontal ones through. So what we would have done in class is we'd have taken our two polarizing filters and would have lined them up and shined a laser beam through them. And you would have rotated them and just watched until the laser beam disappeared. And when that happens, the polarizing filters would have wound up being one vertical and one horizontal like this and canceled out the laser beam. So it's pretty cool. So any particular nemesis in a movie that recommends having sharks with laser beams on its head in order to destroy the protagonist, sure you guys are figuring out what movie I'm referencing. All you would need to do is to get a polarizing filter and you'd be fine. Okay, filter out those laser beams. All right. So, ladies and gentlemen, also recall that our EMR is a transverse wave, not a longitudinal wave. So, a transverse wave, ladies and gentlemen, is a wave that goes up and down as it moves along. Okay, a longitudinal wave goes back and forth as it moves along. Remember these, my epic dance moves from Physics 20? Yeah. Do the transverse wave, or do the longitudinal wave. I'm so surprised that my epic dance moves have not caught on. I don't get it. I just don't get it. I totally get it. I'm being a goof. Yeah, you'd be disappointed if I wasn't this silly. I mean, really. So, ladies and gentlemen, this is evidence for EMR being a transverse wave. And the formal term, besides my awesome dance moves, is that the wave propagation is perpendicular to wave oscillation. Okay, so the wave is going this way and it is vibrating up and down like that. So you've got a nice perpendicular set of information there. Okay, so ladies and gentlemen, polarizing filters can eliminate one of them being transverse. Whereas if it was longitudinal, it wouldn't filter out wavelengths. Okie dokie. That, ladies and gentlemen, actually is the end of this video lesson. That's all we're going to be looking at for today. And we've got some practice problems here for you to chip away at. We've got one on the next page of your notes. And I hope you guys are doing well and that you have a good day. And no fires, injuries, or explosions. And it's getting sunny out there, ladies and gentlemen. So enjoy the nice weather. Wear your polarized sunglasses outside. Wear yourself a baseball hat and put sunscreen on your face. Now, here's something else that's cool about sunscreen. So if you don't want to, if you're done hearing me ramble, you can stop the video now. But what's really cool about sunscreen is it is actually designed to, it's the chemical that actually works to block the UV radiation as a benzene-based compound. Now, those of you who have done Chem 30, you guys will remember benzene. And so there's a compound like this in your sunscreen. And when your UV radiation, so remembering ultraviolet, ultra meaning above, violet meaning violet light, and it's an energy level higher than and frequency level higher than the violet light. And this UV radiation is going to come in and it will then break some of these bonds here in the benzene. And in order to break those bonds, that energy has to be absorbed. And that's why you have to reapply your sunscreen every 2 hours. Not because it washes off when you're swimming, but because these benzene compounds are going to be broken down by that UV radiation. So, ladies and gentlemen, there's some of your practical bits for UV radiation, why sunscreen works, why you need to reapply every 2 hours. And yes, you need to wear it. Otherwise, it will damage your DNA, causing thymine dimers. If you guys took Bio 30, you should hopefully remember that thymine and dimers mean they bond together. And guess what? That leads to mutations, which can lead to skin cancer. So wear your sunglasses, wear a hat, and put on sunscreen. All right. Have a good day, guys. I will talk to you all later. And once again, this is the last lesson for this particular chapter, last lesson for the assignment of EMR Chapter 1. And if you have any questions, get a hold of me on Google Meet. Talk to y'all later. I can't get this to turn off. It won't turn off. All right. Talk to you guys later. Bye.